Hello, this is Gen Jeff, and here we're going to have a brief overview of tables. So, to that effect, I've made the Room of Truth tables. So here we have the truth table for the AND gate. Here we have input 1, input 2, and then the output. Input 1 is this column there, input 2 is this center column, and output is the right column. And we'll pause on that briefly so you can either take notes or screenshot or whatever you want to do. And then we have it here for the OR gate table. Input 1 on the left, input 2 on the center, and output on the right. And we have our NAND gate table. And then we have our NOR gate table. And we have our XOR gate table. And then we have our XNOR gate table. And we'll use this real quick to compare what I've got upstairs I made for the last episode with the tables that we have here. So now that we're upstairs in the room with the using the traditional Minecraft gate, we can see here that both of these switches are off, as denoted by those being dark. Those are lit up, and this is dark as a result, and then here's a negator for going out. And this is our output. So currently, we have an output with no inputs. If I turn this on, we still have an output with one input. Turn that off, turn this on, we have one input, and we still have an output. I turn them both on, and we have no output. So what does that give us? Well, we can look at the truth table here. So we have an output when one is on. We have an output when the other's on and one's off. When we swap which one we're getting a signal from. Then we have an output when both are off, which means we have ourselves a NAND gate right here. So output with none on, output with one on, output with the other one on, and then no output with both on. And that's what we ended up with here. A NAND gate. Rather slow if you do it fast enough, because you can actually see them switch if you go fast enough. So we go back to my load of stuff that is all open. Go back to this. And why is it not giving me the... There it is. Yeah, there we go, too far. So this is basically a series of truth tables I put together in Turing Complete here. When there is, for the AND gate, 0, 0, 0 for the first row. First row here, 0, 0, 0. So when there's no inputs, there's no output. When there's one input, 1, then 0, it's still 0. When it's 0, 1, it's still, again, 0 for the output. Then when there's two inputs, there's an output. For the OR gate, 0, 0, 0 across the board. So neither input has a signal on it, so there's no output. When we have one signal here, there's an output there, so input 1 is on. There's an output. When input 2 is on, there's an output, and when both input 1 and 2 are on, there's an output. So for NAND, it's basically, NAND is the reverse of AND. So when there's no signals going in, there's a signal going out for a NAND gate. When there's one signal coming in for a NAND gate, there's still a signal going out. And then again, when it's switched from input 1 to input 2, there is still a signal going out, but when both signals are on, there's nothing going out. Then for NOR gates, when there is no inputs in either 1 or 2, there's a signal going out for that. When there is a signal coming in 1 but not 2, there's no signal going out. When there's a signal coming in 2 but not 1, there's no output. When there's a signal coming in 1 and 2, there is, again, no output for the NOR gate. For XOR gate, when there's no signals coming in, 0, 0, there's no output. It is still 0. For the XOR gate, again, when there is an input in 1, there is an output. When there's an input in 2 but not 1, there is an output there again. But when there's an output in both 1 and 2, there is no output. For the XOR, or XNOR gate, if there's no signals going in on 1 or 2, there is a signal going out. If there's a signal coming in on 1 but not 2, there's no signal. When there's a signal on 2 but not 1, there's no signal going out again. And for the final one, where there's a signal going in on both, there's an output. So basically, this here is a visual representation of all the truth tables and an error message. Two input-output components are in the same square. Unusable, yeah, because this is the current preview, but you can't actually connect all the things. So we're going to be learning more about Turing complete game as well. So yeah, truth tables. Pretty nice visual representation of all the truth tables here in Turing complete. And then next time we'll have to talk a bit about binary as well, as why I use 1 and 0 in my notes instead of, say, anything else like X and O or whatever. So we'll be talking about binary, and then episode after that will be exploring the limitations of immersive engineering's logic circuit systems that we'll have to be working within and designing around. So I hope this little episode was helpful, and I'll see you next time. Hello, I hope you've enjoyed the video. Don't forget to like, share, and subscribe, and hit the bell icon and all that wonderful fun stuff, because subscribing to YouTube is no longer enough. Hit all the things. Hit the like button. Like the comments. Comment multiple times. And don't forget to share. But subscribe and hit the bell. See you next time. Bye. I think our tank exploded. Whee! There it goes!
The plane or our tank?
Well, there's a tank flying through the sky.